What's up, guys? Got my Hawaiian shirt on, which is my official related rates problem shirt. That's not true, even remotely. A plane is flying directly away from you at 500 miles per hour at an altitude of 3 miles. How fast is the plane's distance from you, that's considered diagonally, increasing at the moment when the plane is flying over a point on the ground 4 miles from you? All right. The first thing that you have to do with a related rate problem is generally draw a diagram. So we're going to draw a diagram so that we can write a formula. Like this is going to be the static version of things. So let's see, 500 miles per hour at an altitude of 3 miles. So here's the ground, and we're going to consider the plane to be flying like that at an altitude of 3 miles. So that right there is supposed to be 3 miles. And how fast is the plane's distance from you increasing at the moment when the plane is flying over a point on the ground 4 miles from you? Well, if you're right here, then let's say that this point right here is where the plane is flying over. So the plane, I'm the worst artist in the world. So let's say plane, yay, there's my plane because it has wings. No, but it's flying over a point 4 miles from where you are. And then we want to know how it's increasing, how its distance from you is increasing. So this distance right here, how that is increasing at the moment when it's 4 miles from you. Remember, when you solve a related rate problem, you have to write a static relationship, and then you take a derivative so that you get some primes that pop up. So let's look at this. Its distance from you will be related by these quantities. The 3 is always 3 because the plane is flying at an altitude of 3 miles. So this 3 is constant. That means that we're not going to use a variable to denote that value. But the distance along here, the distance on the ground between you and the point directly underneath the plane, that is variable because as the plane flies, that's going to change. It's going to get larger the farther the plane flies away from you. So let's call that x. And the equation relating these, the static relationship, the one that doesn't yet have derivatives, is based on the fact that this is a right triangle. The plane is flying at an altitude of 3 miles. That means straight up from the ground, 90-degree angle. So we've got x squared plus 3 squared equals d squared. Okay, let's also interpret the other information in the problem. Flying directly away from you at 500 miles per hour. 500 miles per hour means that it's going 500 this way. But what does that give the rate of change of? Well, as the plane flies away from you, this distance here, the distance between you and the point directly under the plane, wherever it happens to be, that distance is going to be increasing. So really what this is a statement that dx dt is equal to 500. It's 500 positive, not negative, because the distance between you and the point under the plane is increasing, not decreasing. This is what you might call ground speed if you were doing a physics problem. How fast is it moving relative to something on the ground? So how fast is the plane's distance from you increasing at the moment when the plane is flying over a point at the ground 4 miles from you? Well, we'll say that that's meant to say that x equals 4 at the instant we're talking about. So static is x squared plus 3 squared equals d squared. And then you take a derivative. We're going to differentiate that. That will be 2x. But remember that x is a function of time. So 2x times dx dt, that's the chain rule, baby, plus 3 squared, that'll be plus 0 because that doesn't change. And that's going to be equal to 2d times d dt. Oh, now I wish I had chosen a different letter for that. Tell you what, let's make it capital D, just because. Okay. That's going to be equal to capital D squared. This will be D squared, and then this will be D, capital D. Oop, and right there. Okay, so what do we know here? We know that x equals 4, so we can swap this out for 2 times 4 times dx dt. We already figured out that the information in the problem indicates that's 500. So 2 times 4 times 500 equals 2 times d dt. Now we're looking for this, right? But oh crap, we don't have what d is, except that remember, when you get frozen later in the problem like this, and it's like, oh, there's something from the static relationship I didn't know, you can plug back the static information into that and find out what it was. If x is 4, then guess what this needs to be? I bet you're already thinking it. If x is 4, then this means that it's a 3, 4, 5 triangle. So x is 4, d is 5. So this is going to be 2, looking over here now, this is going to be 2 times d. Well, that'll be 2 times 5 times d dt. And let's see, how fast is the plane's distance from you increasing? Well, that actually is great because this means that the only variable left is the variable we're interested in solving for. We want to get the rate of change of the distance. So the only thing left to do is to algebraically solve for that. 2 times 4 is 8, times 500 is 4,000. This is 10, so 4,000 equals 10 times d prime, which is what d dt means after all. And so d prime equals 400. At the end of a related rate problem, because the answers are usually physical, you do say miles per hour, or if you want to phrase it the same way as the original problem, you can say mph, like that. There you have it. Cool, huh?